So let's look into the second derivative. What does it mean to be a second derivative? It's just the derivative of the first derivative. So if we say f of x equal to something, we want to take the derivative, it's gonna be f prime of x. And then we want to take the second derivative. What we do is we take the derivative of this function. That will be f prime double of x, f double prime of x, okay? And this also can be written as d dx of dy dx, which means this is the derivative of the first. This is the same thing. The f prime of x can be written this way, and this is meaning the derivative of the first derivative. This also can be written as d square y dx square. This is a recall from the last videos that if we have a function that is f and it is increasing over an interval and we want to graph its derivative, the first one, it's gonna be a positive. And if the function is decreasing and over an interval, then its first derivative gonna be a negative. Similar, we can apply the same thing here to the second derivative, since the second derivative is the derivative of the first derivative. So that will say that says if we have the graph of the first derivative and it's increasing over an interval, then the second derivative gonna be positive. Let's take these two examples now. So we have two functions here. We have this function and then we have the second function in here. This function, this shape called concave up, and this shape is called concave down. Okay, now we want to find relation between these shapes to the first derivative and the second derivative. So let's do that. Here, if we want to find the derivative on this side, what's gonna be, we have a negative slope here. This is a tangent line, it's negative slope, so that means the first derivative is negative. Okay, and here this is the opposite. We take this point and we draw a tangent line to it, the slope is positive, which meaning the first derivative is positive. And here there is no slope, therefore the slope is 0, so the first derivative is 0. So notice this is that here we are going from negative to a positive, okay? So that means f prime is increasing, and we said if it's increasing, then f prime is positive, okay? F double prime is positive. And similar thing, and then we can do the same thing for this function. For this side, we can notice that slope here is positive, okay? So the first derivative is positive, and here it's negative. Okay, so the derivative is decreasing, which means f double prime is negative. So now, from these two shapes, we can relate f of x and f prime with its f double prime. So they're all say if f prime is positive, then that means f prime, the first derivative, is increasing over that interval, and over that interval the original function is concave up. Similarly, if f positive is negative, if f double prime is negative, that means that f prime is decreasing over that interval, which means the function is concave down. So when we're graphing the first and the second derivative, we will use these rules, which first, this rule, the relation between the function and the first derivative, and it's this rule again to relate the function to the first derivative and also to the second derivative. Now, before we move on, let's make a note about our rule, okay? So, let's give an example where f of x is x to the fourth, and we want to find f of x and then f prime of x and f double prime of x. Here, what we can do is, first let's graph it. Gonna be something like this. Okay, this is f of x, this is x, and this is y. Now, if we want to take the derivative, we can use the power rule, which is f of x as 4x to the cube, and we want to use the second time, gonna be 4 to the 3x to gonna be 12x squared. Okay, so what does that mean? It means that f prime of x gonna be something like this, and then f double prime of x gonna be something like this. So notice here, this is the function here is concave up, okay, which means if it's concave up, then the second derivative should be positive. But notice at this example, this is the second derivative. It's not positive all everywhere. So what we notice in here, that is the second derivative is not all positive. When you see there is, when we draw it, at x equals 0, it's actually 0. That's why we mentioned that second derivative can be greater than or equal to 0. So this is just a note, so just put that in mind. We will not use it that much.